Okay, before we get into the sections that we're going to cover today, I just want to remind everybody that your first test is due this Sunday at midnight. So the things that are going to be due Sunday at midnight are review for test one, and then what we're going to cover today, which is 7.1 and 7.2. They're both really short. When you do take your test, I am going to need to see your scratch paper that you use for your test, not your review, just your test. I think the easiest way to do that is just to get your phone and take a picture of it, and then go to your text messages, and instead of typing a phone number that you're going to send a text to, type in my email address, which is sohanson@uaptc.edu. And then attach your pictures of your scratch to that text message. If you have any issues with that, just let me know and we'll figure out another way. I just think that's probably the easiest way, because I feel like most people know how to take a picture with their phones. So again, if you just take a picture with your phone and then just go to your text message to create a new message, just put in my email address right there in the to part. And then attach it however you attach pictures on your phone. Okay? If it's an iPhone, you probably just hit this button right here to attach the pictures. Okay? Now, let's get into 7.1, which is talking about symmetry and how graphs are symmetrical. Sometimes they're symmetrical with the x-axis, sometimes they're symmetrical with the y-axis, and sometimes they're symmetrical with the origin. If you are symmetrical with the x-axis, you would look something like this. Here's my x-axis, the one that's horizontal, that goes straight left and right. Look at the top of the x-axis compared to the bottom of the x-axis. They exactly mirror each other. The top looks exactly like the bottom. Or in other words, if I folded my graph along this axis right here, the top of it would come and lay down right on the bottom of it. That's what it looks like if you are symmetrical with the x-axis. If you're symmetrical with the y-axis, and this would be what's called an even function, and we'll get into that in the last couple of problems. If you are symmetrical with the y-axis, here's your y-axis, it's the one that goes straight up and down. The right side and the left side mirror each other. They are exactly the same on the left side of the y-axis as it is on the right side of the y-axis. Now, here's the one that's harder to see. The one that's, if you're symmetrical with the origin, that would mean you are symmetrical with both the x and the y-axis, which means if you folded it on the x-axis and then folded again on the y-axis, then the graph would, the one half of the graph would lay on the other half. I think the easiest way to look and tell if something is symmetrical with the origin is if you actually have it printed out, like this number 1. If you are symmetrical with the origin, your graph right side up looks exactly like your graph upside down. So if you can turn it upside down and look exactly the same, then you are symmetrical with the origin. So if you're looking at this, you'll notice over here it starts down here below the x-axis. So remember that, below x, comes up through the x, then back down through the origin. It ends up right up here above the x-axis. Well, look what happens if I turn it upside down. It's the exact same thing. Starts off below the x-axis, travels up through, then turns back around, goes down through the origin, and does the same exact thing whether you are right side up or upside down. Same graph. Okay, so that's what symmetrical with the origin looks like. If you are symmetrical with the origin, you are called an odd function. Okay, even functions, the way you tell if you're not symmetrical whether you're even or odd, even functions, their end behavior, which means the end of their graph, goes in the same direction. These both go up. Odd functions, one side ends up going down, like this one's still going down. The other side ends up going up. That's the difference between an even and an odd function. So let's look at some of these, like looking at number one. Number one is kind of, well, I just showed you. There's the function. It's going to ask you if it's symmetrical to the y, no symmetry, origin, or x. Okay? So if you turn it upside down, you'll notice it's the same exact graph. So that means it's symmetrical with the origin. Okay, let's look at what number two looks like. There's the x-axis, the y-axis, and the graph looks like this. Okay, I'll just show it to you. It looks like that. So again, it's going to ask you, is it symmetrical with x, y, origin, both x and y? Which one is this mirror? What's it mirroring across? Well, it's the same exact thing on the right side of the y-axis as it is on the left side of the y-axis, which means it's symmetrical with the y. Right, number three. Again, there's my x-axis. There's my y-axis. The graph looks like that this time. So this time, it's exactly the same above the x-axis as it is below. If you folded your graph on the x-axis, wouldn't the top just come and lay directly on the bottom? The graphs mirror each other on top and below the x-axis. So this one is symmetrical with the x-axis. All right, the last two are asking whether or not the functions are even or odd functions. Okay, number four looks like this, and it asks, is it even, odd, or neither? So remember, an even and odd, even is respect to the y-axis. It's symmetrical with the y. Well, here's my y-axis. Is it the exact same on the left side as it is the right side? And it is, right? If you want to see it more exact, here's exactly what it looks like. So you'll notice that this side of the y-axis exactly matches the other side of the y-axis. So it's symmetrical with the y, and the ones that are symmetrical with the y-axis are even functions. So that one would be an even function. And then the last one in this section, I told you it was short. See if I can recreate this. So again, it looks something like that. So here is my y-axis. And one side does not exactly match the other, so it's not symmetrical with the y. Here's my x-axis. If I folded it along that, which means this part would come down here, which means this part of the graph should be reflected right here, and it's not, right? If I folded it on there, I would see a little U shape right here from this flipping over here. I don't see that. But look what happens when you turn your graph upside down. So get a good glimpse of it there. Turn it upside down. Is it the exact same graph upside down as it is right side up? Which it is. Which means this one is symmetrical with the origin, and all functions that are symmetrical with the origin are odd functions. So that one is an odd function. Okay, so that's the end of 7.1. Now I'm going to write some things up here for 7.2. I'm going to write the shapes of all the graphs that you're going to see pretty much this semester and what makes them be that shape. And then we're going to talk about what happens if you have, what moves the graph around. What transforms it? What moves it left and right? What moves it up and down? What flips it upside down? What types of things make those certain things happen to a graph? So let's first of all look at the different shapes of graphs we're going to be dealing with. The first one is just an X graph, which means if it's not squared or cubed or absolute value, if it's just X, it's going to be some sort of line. X squared graphs are the parabolas, the U-shaped graphs. That's if your highest exponent is a 2. X to the third graphs are the squiggle shape. They start at the bottom, they squiggle through the origin and end up going up. Absolute value graphs are the V-shaped graphs. Let's see what else we're going to have. Oh, we have a rational graph. What if you have 1 over X? This graph will look like that. And there's 2 more that you're going to see in this section. There's a square root graph and a cube root graph. The square root graphs, like that, and cube root graphs kind of look like a sideways X cube. So there's the 6 different shapes that we're going to focus on pretty much the rest of I don't think you'll see anything else besides this the rest of the semester. Those different shapes of graphs. Now, sometimes you'll have a graph and it'll be, say, an X squared graph, but it's not going to be centered right at the origin. It's going to be up and over or down and over. What makes that happen? Okay, the numbers that are with the graph are what shift it left and right and up and down. So let's look at what makes those shifts occur. They're called transformations. Okay? Outside, and you'll see what I mean by outside here in a minute. The numbers on the outside, numbers move the graph up and down, up or down, and you go with what the sign is telling you to do. So if there is a plus on the outside, you go up. If there's a minus on the outside, you go down. The inside numbers. Shift the graph left or right. But you go opposite the sign. What I mean by you go opposite the sign is a plus will actually move you to the left. A minus will move you or shift you to the right. So again, outside numbers, shift the graph up and down. You're going to go with the sign, which means if you have a plus 5 on the outside, you're going to go up 5. Inside numbers shift you left and right, but you're going to go opposite of what the sign, what you would think the sign is telling you. A plus actually shifts you backwards or to the left. A minus will shift you to the right. So let's look at some of these. Number 1. You have y equals x minus 8 squared. And the x minus 8 is in parentheses. That's what I mean by an inside number. Numbers that are inside parentheses or inside absolute value bars or inside a square root. An outside number would be out here. Something that would be outside of the parentheses. So that's what I mean by inside and outside numbers. So the first thing that you're going to be asked is, what kind of graph are you about to draw? What shape is it going to have? That's why I put all those different shapes up there, and what tells you what makes that is the exponent. Or if there's an absolute value bar, or if it's a square root. That's what gives it its shape. So you're going to have to tell the graph that you want to start off with an x squared shape, which is going to make a parabola. Now, the shifting. This is an inside number. What do inside numbers tell me? They tell me where the graph shifts left and right. So since this one is minus 8 on the inside, it's actually going to shift it to the right 8. So when you graph it, and I'm about to show you what it's going to ask you to do here in a minute, you're going to have to tell the graph that you want to draw a U shape. So you'll go over there in the toolbox and click that shape that you're going to make a U, and then you're going to have to tell it to shift. And again, I'm about to share my screen and tell it and show you how to do that. So once you click this, you can click anywhere on here. It's going to make a parabola right that's centered right there at the origin. Then there's going to be the instructions down here on how to shift, and I want to shift it to the right 8. So 1, 2, 3, 4, 5, 6, 7, 8, which will move your parabola to the right 8. Now, I'm going to share my screen real quick just to show you how you're going to do that on, I'm going to go to number 1. So this one says y equals x minus 3 squared. Okay, so that means this one again, it's going to be a parabola and it's going to be shifted to the right 3. So the first thing you're going to have to do is come over here to this multiple choice. These all, you're going to put an x squared in the box, and you want to choose the one that says shift the graph 3 units to the right. So you would come here, this is the one that says 3 units to the right, type in the x, and then come down to this palette down here and click the one that shows the little blue box where your exponent should be. So you can type a 2 in your exponent spot. So I'm going to shift the graph of x squared 3 units to the right. Now it's going to ask you, click to enlarge graph. So before you do anything, look up in the yellow rectangle. It says click the graph, choose the tool in the palette, and follow the instructions to create your graph, I guess. Yeah. So I'm going to come over here and pick the parabola, the x squared tool. Once I've picked it, I can actually come anywhere on the graph, even if I click way up here in the corner. It puts my x squared graph right there at the origin, right in the middle. So now down here is where you're going to do your shifting. So first of all, look at this. This one says vertical stretch, shrink, horizontal stretch, shrink. We're not doing any of that. We're only doing vertical shifts and horizontal shifts. So this one is a horizontal shift, right? Because it's talking about left or right horizontally. So I need to shift it to the right. You'll just move this box to the right 3, and look what it's doing to my graph. My shape of the graph, once I shifted it to the right 3, it moved it from the origin over to the right 3 spots. And then save it and check it. Okay, so again, you're going to tell it what shape and then do the shifting instructions. Okay? On number 2. You have g of x equals x minus 9. So you're going to start off with the graph of y equals, it's just an x, right? So since it's just an x, you're going to start off with that. This is an outside number. If it was an inside number, it would be in parentheses or an absolute value bar or something like that. So since it's not, that's an outside number, which is going to shift this graph down 9, right? Because outside numbers shift you up and down, and you go with the sign. So a minus 9 will shift you down 9. Now, after I explained all that shifting, when you're graphing this one, since it is a line, it's actually going to do the old school method. Instead of doing the shifting, you're going to have to plot 2 points on that graph. Okay, so then to plot those 2 points, remember the easiest way is just to go to your y equals, turn it on. Go to your y equals and put in that x minus 9, and then hit your second table button, and then choose any of those points you want to plot. All right, number 3. h of x equals 1 over x plus 5. This one is a multiple choice problem. The 1 over x, if you go back to the very beginning of the notes on this section, you'll see that that's a rational function, and the 1 over x, if you're looking at the x and y axis, that's what the graph of 1 over x would look like. What is this going to do to it? It's going to shift the middle of this graph up 5. So this is going to move up 5, and that part's going to move up 5. So this one is multiple choice. So when you're looking at these, it looks like your A is the one I drew on the board. Do you see how it's centered right there at the origin? Look at what B has done. It has moved that graph that started off at the origin. It moved it up 5. So that's the one you'd want to choose. This is a rational graph, but it's moved down. It looks like 5. So you would pick the one that, since it's plus 5, wherever it is, plus 5, that moved it up 5. Number 4, g of x, oh, we have something new here, equals negative, open parentheses, x minus 7, close, to the 3rd power. Before we see this one, what happens with that negative is it's going to do what's called reflect your graph across the x-axis. The easiest way to think about that is it flips your graph upside down. Let me show you what that would look like on an x squared graph, because it's a lot easier to see a parabola flipped upside down than it is the x cubed, which is what this one's going to be. A parabola, if it had the regular graph of x squared would look like that, right? Just be a U shape. If you had the graph of negative x squared, it flips your graph upside down. This is what negative x squared would look like. So that's what the negative does. It does what's called reflect your graph over the x-axis. That's the technical way to say it. The easiest way to see it is it flips your graph upside down. So let's look at what's going to happen with this x cubed graph, right? It's going to have the x cubed shape, which means it's going to start off like that. The inside number, what do inside numbers do? They shift you left and right horizontally, but you go opposite the sign. So since this is a -7, it's actually going to shift me to the right 7. This negative is going to reflect me across the x-axis. So I'm going to do this one in Math Lab so you can see what's going to happen with that. So I'm going to go back to Math Lab. And go to number 4. So you can see how to make this happen. This one says negative x minus 9 cubed. So it's the exact same as this one, except it's just going to be shifted to the right 9. So I'm going to do start with the graph of f of x equals x cubed. Choose the one that says shift it right 9, and then reflect it across the x-axis, not the y-axis, but the x-axis. So this bottom one right here says shift it to the right 9 and then reflect it across the X. So I'm going to choose that one, type in my X, go down here for my little exponent button, and put in 3. So X cubed, shift it right 9, and reflect it across the X. So let's see how we make that happen. So come over here and tell it what you're about to graph. So the one I'm on right now, if you hover over it, it tells you that's the X cubed tool, which is what I want. So I'll pick that one. Now, remember, if you're doing the shifting method, you can come anywhere over here and just click it. So it automatically puts the X cubed graph right there in the middle at the origin. Now I need to tell it 2 things. I need to shift it horizontally to the right 9. So I'll come down here to my horizontal shift, go to the right 9, and you can see it moving it on the graph. So I moved it to the right 9. Now I also need to come down here. We're not going to do any reflecting over the Y, so don't worry about that. Reflect it over the X. Now when I click this, watch what it does to that yellow graph. It flips it upside down. And then save it. Okay? So that's how you would tell MathLab to do what you want it to do. All right, number 5. Let's see, I've got g of x equals, in parentheses, x plus 2 squared, and then outside minus 3. So a couple of different things are happening. It's going to say, what are you going to start off with? What kind of graph? What's your exponent? Since it's a 2, I'm going to start off with the parabola graph. And then I'm going to shift it 2 different ways. I'm going to shift it, my inside number tells me my horizontal shift. So since it's plus 2, I'm actually shifting to the left 2. My outside number tells me up or down. And I go with the sign now. So my outside number tells me to shift it down 3. So x squared graph, left 2, down 3. So that's what you'll tell it in your shifting when you're graphing it. Number 6. F of x equals the square root of x plus 9, with the plus 9 still under the square root. And this one's multiple choice. So it's a square root graph, which means it starts off like that. Then that would be right at the origin. So that's what an original x squared graph looks like that hasn't been shifted anywhere. But where do I need to shift this one? That's an inside number. If it was an outside number, it would be outside of the square root over here. So an inside number shifts me horizontally, left or right. Since it's a plus 9, I'm going to go to the left 9, which means the shape of this graph would move to the left 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my graph would start here now and travel that way. So again, it's multiple choice. They're all square root graphs. One shifted up, one shifted down, one shifted left, and one shifted right. So you would just choose the one that's been shifted to the right 9, which looks like this D one. Oh, not right 9. Whew, my bad. Plus 9 would move it left 9, right? Which would be B. I guess I was looking at that. That's totally wrong. I wasn't at that at all. Okay, 2 more. Number 7. equals the cube root of x with a -3 that's not underneath the radical symbol, which means that's an outside number. So what do x cubed graphs look like? They look like that. This is a multiple choice one also, so you're not going to be graphing. You're just going to pick which one does the correct shift. So this one's going to be a vertical shift, right? Up or down. Outside numbers are up or down. You go with the sign, which would mean this needs to be shifted down 3. So you pick the one that has the x cubed graph. They all have or cube root of x graph. The one that's been shifted down 3 would be this A. All right, last one. G of x equals negative, open parentheses, x minus 5 squared plus 3. So 3 different things are happening here. You're going to start off with an x squared. Do the horizontal shift first. And this one's going to actually be like, it's going to give you some blanks. On the first blank, you'll have this drop-down menu. So that's going to talk about the horizontal shift. So where am I shifting horizontally? This is a -5, which means I will shift to the right 5. The next drop down is going to ask you about the reflection. It's going to say, does this reflect over the x-axis or the y-axis? This negative out front tells me it reflects across the x-axis. It flips upside down. And then the last drop down button tells me up or down shift. So since this is an outside number, it shifts me up or down. I go with the sign, which means I'm going to shift up 3. And that is it for 7-1 and 7-2. So remember, Sunday at midnight is review for test 1, and 7-1 and 7-2. Do Sunday at midnight. If there aren't any questions, then y'all have a great weekend.